Hello everyone, August 27th. Alright, second day with skateboarding. I think I'm getting a little bit better than yesterday. Still visible progress of pushing. Kind of started feeling that I can push and stand with one leg on the skateboard. So I consider that progress. But I'll keep doing this. The goal is to master a few. So I need to do pushing, right? And then I need to slow down, need to stop turning by tip the skateboard, and ollie, need to learn ollie. Like all of these are the skills I want to learn. Probably that's the most I want to do, because I think after I learn how to do ollie, I will be comfortable actually doing it on the road. So yeah, I have a few more days, because next Tuesday I have to report to work. All right, let's see what we have today. Count sub-islands. We have two n by n binary matrix, grid 1 and grid 2, containing only zeros and ones. Zero is water, 1 is land. An island is a group of ones connected four directionally. Any cells outside of the grid are considered water. An island in grid 2 is considered a sub-island if there is an island in grid 1 that contains all the cells that make up this island in grid 2. Return the number of islands in grid 2 that are considered sub-islands. So so I need to find the islands in grid 1. Okay, let's say I find the island, and in grid 2 I can find islands as well. Okay, now the question is, how do you know the island in grid 2 is a sub-island of grid 1? A sub-island is included, right? So what I can do is either union find on island 1 on grid 1, okay? And after the union find, then I go through grid 2 and I'm start to color it. Yeah, I'm starting to color it, which means I'll go through every cell in here and we'll try to color, put the island index in here for here, right? And then how big is it? 500, 500. And then we can do color it. Oh, and if it's a 1, right, I color it with whatever is there. Okay, if it's 1, I color it basically because after union find here, I will get a index. Right? So basically, what I'll have here is 1, 2, 3, 4. 3, 4. So I can say these are 1s, And these are zeros. These are 2. These are 3, right? And then on this new 1, 2, 3, 2, 3, 4. 1, 2, 3, 4. So I go, if it's a 1, I check here to see what it is. It's a 1. 1, 1, 0, 0, 0, 0. I check this is a 1, 1, 1, 0. Check this is 0. Right, which means it's not an island. So I can just set it to 0 because it's not. 0, 0, 0. This is a 2, right? 0. It's a 1, but it's a 0, right? 0, 0, 0, 2, 0, 3, right? It's a 3, and this is 0. Okay, so this is a union find. This can be considered as their parents. All right, and then I'm going to go through this. The union, 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 union. Like if I union this, so each one I union with 4. If I union the ones nearby and it says it's already part of it, then we don't change, right? That means we're good. That means we have that is a sub-island, right? We go through everybody, and then when you do the union, it's already been unioned, right? That means you are a sub-island. And in this one, it's a 1 by itself, but I check its parent. So now this one has nothing to union, right? Nothing to union, and the previous is a 0, which means, yeah, this one just doesn't consider. This is also, but the previous is 2, so this one is considered. And this one is considered. Now, here is the thing. These two, they belong to the same, but here they're separate. Ugh, they're separate. So they're a part of the island. Okay, so maybe what I do is, if it belongs to an island, I set it to, to 1. It's just part of the island. It doesn't really matter which island it belongs to, right? It's just part of the island. Now, the question is, what if, yeah, they belong to, what if I say the previous island is 2 islands, and then we have this. Is this considered? That should not consider, right? Hold on, let me see. I think it should return 2. What I'm trying to say is, if here, 1, 1, 1, I set 0, this is 0, this is also a 0. So basically 1, 1, 1, 0, 0, 1. So we have 2, right? But they are all here. But this one doesn't count. So now this shall return 2, which only these 2 are considered sub-island, because this island is not part of the bigger island. See, this is okay. So basically here it's island by itself, right? And I check it does belong to, so that's good. Huh. Okay, so maybe we do union find here, we do union find here. And for all the islands, we get them out and see if they belong to the same. I think that would be easier to do. 2 rounds of union find and then we're good. Okay. I think this one will work. 2 rounds of union find. Class DSU. Alright, so what do we need? We need parent rank DSU this dot parent new int okay, and then int find parent. Now if this dot parent x is not equal to x, parent x equal to this find right? So this is find union equal to py. Otherwise, rank px py equal to px. This dot rank px. Okay, so that's union find. Here we have to say m the grid 1 dot length grid 1 DSU I think it's m times n. Private n. Right. Okay, and then int and grid I j equal to 0. We'll continue, right? If it's not, it's 1 and its neighbor is also 1, then we say dsu.union. Oh shoot, union what? Oof. I times n plus j, right? I times n plus j. Yeah. That union ni times n plus nj. And I'll return DSU. Okay, as union find. So we can say union find grid 1, right, and then grid 2. Okay. Now what I need to do is go through that and see if they all belong to the same, right? Okay, so we're gonna go to DSU2, right, and find the one that is group them, group everybody out. How do we do that? We need to use a map, right? I need to use a map. Okay, so we say islands. Islands 2. Then 4. Int I equal to 0 I smaller m times n plus plus. I'll find. Then we say int p shall equal to dsu2.find I. Int water. Yep. I'm not gonna do this way. 0 I smaller than m I plus plus. It'll be easier to do it this way. J is 0, j small n, j plus plus. Right. Parent is DSU2 dot what? Actually, it's fine, right? ds2 dot find I times n plus j, right? That's the parent. And if islands2 dot put if absent p new array list islands dot get p dot add I times n plus j. Okay. If grid 2 I j is equal to 0, water equal to p. Okay, so now we go through all this. I have water, right? Then we need to go through all the keys, and then we'll go into DSU1 to see if they all have the same, right? They all have the same parent. So res 0 for int of islands2 dot key set if p is equal to water, continue. Otherwise, we're going to say for int island of island2 dot get p. Okay. Int so these are islands, so I need to check its int grid 1, no, DSU1 parent set it to -1. Actually, no, we should do this one here. Okay. So I have island. Now I'm gonna check int pp dsu1 dot find island. Oh, we also need to know if that is water, right? We need to know that is water. Oh, union find grid 2 okay. So I go through grid 2 and for each island, if it's water we skip, otherwise we set this. Now I get the island. See, that is the thing, we don't know the water in the first DSU. Okay, let's put water in here. So int this, int water. Okay, and it's okay. So we'll go if Because all the water need to be union together. Okay, so we go this, and this shall equal to grid ni, no, not ni, I, j, right? We union them, right? If we union them, and what if the water does not? Holy crap. Okay. This star water equal to n plus 1. Okay, so this is something that it will never be assigned, right? It will never be assigned. Okay, so with that, yep. Now we can do it. So basically, we can say this is equal to 1, and we can say if grid ij is equal to 0, right? And then we manually will set say dsu.parent grid I times n plus j equal to dsu.water, right? And then continue. Just don't do it. Otherwise, we do the regular thing, right? So blah blah blah. We don't need this water, right? We don't need this water. We just say int p is this, and we say if p looks great. Wait, hold on. It's fine as parent is not equal to itself, right? It's not equal to itself. So we need to find okay. So if this dot parent x is equal to this dot water, then we just return this dot water. Hold on. If it's not equal to this, and this dot parent x is not equal to this dot water, under this situation you do this. Otherwise, just return water. Okay, so now you can return water. That's a difference. So we can say if p is equal to dsu2.water, right? If it's a water, then you just continue. Don't handle it. If it's water, we don't do it, right? If it's not water, then you get it. Then we can avoid this. Then there's no water, right? There's no water. And then we can check the DSU1, the parent of DSU1, to see if they are all unique, all the same. And then we say for all the island, we'll find its PP, right? And we say if PP is equal to DSU1 dot water, right? If it's a water, that means it's not part of it. Then we'll do DSU1 parallel equal to -1, and then I'll break it out. Okay, now I'll break it. Okay, I'll break it. Otherwise, it's not. Then we'll say if it's equal to water. else if DSU1 part is equal to -1, that's the first time, then I'll set DSU part equal to PP. Else if DSU1 part is not equal to, so basically if PP equals to this, or PP is not equal to DSU1 parent, right? So if we go DSU1, we find it. If it's water, done. If we find its parent in DSU1 and it doesn't equal to the previous, which I have to, because this one have to go first, right? Yeah, if it's equal to water, then we set it to this, we break it. Okay, now PP is not equal to water, then we check. If DSU1 has not been set before, we set it. Okay, if DS has set before, but it's not equal to PP, we'll treat it the same, which is DSU1 parent we set to -1 and we'll break. Else is equal, right? It's DSU1 parent is equal to PP. And when that happens, that's good. So we just keep going. And at the end, so what I think is, if DSU1 is equal to -1 and the PP is not equal to the water, then I get this, right? Yeah, that's Samir. Then I say else if so DSU1 is not equal to -1, right? So I want to combine these two conditions in one. How do I do that? Yeah, I think I can do it this way. Actually, no. Putting here. So I say if this is equal to and this is not equal to, then we will do DSU1 parent equal to PP, right? This is previous is this, and PP is not a water, then we do this. Else if, okay, else if DSU parent is equal to, so else if PP is equal to DSU water, yeah, we can say PP is equal to DSU1 water, or DSU1 parent is not equal to PP, then we'll set it to -1 and it'll break. So this is the only situation that will set PP, right, to DSU parent. And these are the only two situations, because we check this first, right? We check this first. So if this one does not work, so either DSU1 part is not -1 or PP is equal to. So if this, then we set this. If it's not -1, then we will always check here. If this is not, but this is not, so yep, okay. So now when we get out, what we're gonna say is res can plus equal to DSU1 par is larger or equal to 0, then we'll plus 1. Otherwise, we'll plus 0. And at the end, we'll return rest. Okay, let's check this one. Check this. Madre mia, that is not right. Okay. Maybe we need to find. Let's do here system.out.println islands2.getP dot toString. Let's see if anything got printed. I have only 1, 0, 1, 2, 7, 8, 9. Huh. They're all together. That is bonkers. Something is wrong with the union find. So I go through everything, right? And then I have, these are the 4 directions. And I say, if it's equal to 0, then we will set it to dsu.water, which is fine, and I'll skip it. Otherwise, I'll get next j, and if it's within, if it's not within, and if it's equal to 1, then I will union them. It looks good to me. Interesting. Oh, I know what happened. I got the parent wrong. God. Yep, I forgot about this step. That's okay. That's okay. We made a mistake in union find. Normally we don't make mistake in union find, but yeah, it happens. Let's try it again. All right, so now the only worry is this my timeout. My timeout. Okay, let's see if it's going to time out. It's a 1905. 2 rounds of union find to produce all the islands on grid 1 and grid 2. Then we go through, right, each island in grid 2 and check whether they all belong to the same island in grid 1. That's it. and I use union find. I mean, typically you do that, but you also don't need to do union find. You can do anything, right? You can do anything. You can do DFS, BFS. It doesn't really matter. So MN for sure times, O union find. I mean, I like union find. I think it's easier to write, but I mean, DFS, you can do that as well. Yeah, I'll do DFS. So you start from here, something, you DFS, and then you set up a, island. Yeah, it's basically the same. Yeah, you can DFS, and then you go through the same thing. Yeah. Of course, one can also use, DFS instead of union find to get all the islands. Yeah, I can see that one working, so definitely there's another way. I don't know, just whenever I see problem like this, the first thing in my head is always union find. I really enjoy union find. I mean, it's not the fastest because probably union find is taking a lot of time. Make me wonder, right? Make me wonder if we can make it faster. How do you make it faster? Well, we can do essentially the same thing, right? Essentially the same thing. So what we're gonna do is we will rewrite this right now. Okay, we'll rewrite this right now, and instead of union find, what we're gonna do is we'll change grid in place. Private Oh, I heard that. No, of course, DFS. I don't know why. Really? Well, I haven't used it at all. Yeah, I've been using this. So we're gonna DFS this int I, int j, right? We're gonna DFS this. And how do you know that it has been visited or not? We set it to oof. Negative value. Or we can start from 2. If it's 1, that means it hasn't been visited before. If it's 2, okay, so we're int island, right? So we'll copy a few things. For example, I like this one. I will use this here, sure. Yeah, so basically ij red ij equal to island, right? For int dir of dirs, int ni I plus dir 0 and j plus dir 1. Come on, right? And we say if, same thing, ni large equal to 0 and ni is smaller than grid. Let's do this. m grid dot length and grid dot 0 dot length. Right, this is m, and in j larger equal to 0, and in j is smaller than n, and grid ni in j is equal to 1, right? Is equal to 1. When that happens, we'll say dfs ni nj grid island. Yep. Okay. This is going to be void. We're not going to return anything. So 0 gets skipped, and the visit ones also get skipped. So once we're done, we'll return. Okay, that's fine. And I'll redo this grid.length. One. Grid 1 dot 0 dot length. Okay. And then what we need to do is for I 0I smaller than m I plus plus j 0 j smaller than n j plus plus. Okay. Next is if grid 1 I DFS. That's DFS, so we have another private void. Find islands. Okay. So we have grid. Okay, and basically all of this can go, right? D6J, so we can put here, and if grid IJ, oh, hold on, int island, start with 2, okay? If this is equal to 1, okay, and then we do DFS IJ grid island. Right. Once we're done this DFS, so this DFS will give us also island plus plus, right? Then of course we also don't do anything, so we have first do find island grid 1, find island grid 2. Okay, so now the 2 islands are found. Then what we can do is we'll go into use this, because we're gonna get all the islands out. Okay, so I think this one's good. All right, we'll get all the islands out. I wonder if it's possible. All the islands out, and when I say if grid 2 ij equal to 0, continue. Otherwise, grid 2 ij. Oh, because I need to group all of them together. That's the thing. I need to group all of them together. So why don't you produce it as you're going through? Yeah, why don't you produce it as you go through? So we need to do DFS, right? And while I do DFS on island 2, I'll check. So this is definitely, so DFS 1, okay. We do DFS 2, grid 1, grid 2, island 1. We only need island. Oh. We only need island 1, right? All right, so we will do grid 2. I'm visiting it, so I set it to 0. Okay? And all I need is to check if it's equal to island 1, right? So basically, true or false, right? So this one gonna be Boolean value. So DFS 1, that's basically just DFS grid and mark each island, and mark each island, and distinguish, not mark, and distinguish each island in place. DFS 2 is DFS grid 2, right? And check whether its island is contained within the corresponding island in grid 1. If yes, return true. Otherwise, false. All right. So we have this, we set grid 2 to 0. Direction, blah, blah. So if we set it to 0, right? And we need to check if it's because each one I go in. Yeah, so we need to check is if it's equal to island. Okay. If grid 1ij is not equal to island 1, return false. Okay. Otherwise, blah blah blah. We go for grid 2, right? Otherwise, we do this, and we don't call it DFS 1, DFS 2. We call it DFS find island. Okay. DFS find island, and this is called DFS check island. Okay, we do DFS check. Right, check island ni nj grid 1 grid 2 island 1, right? So if this, we say if not, right? If it's not, return false. Otherwise, when we go through everybody, return true. Okay? And this is find islands. We use DFS find island. Okay? So find islands do this, alright? And then we need to say for int I equal to 0, I smaller than grid 2 dot length, I plus plus, for int j equal to 0, j smaller than grid 2 0 dot length, and j plus plus. Okay, now it is the thing, right? Now it is the thing. Int res equal to 0. Now it is the thing. What is the thing? So if but I have to go through the whole thing, right? I have to go through the whole thing. I have to go through the whole thing. Oh my goodness, so I have to go through the whole thing. Because if I don't go through the whole thing, yeah, I need to go through the whole thing. Just do not do it that fast, right? Okay, so boolean check island is sub island true. Okay, is sub island shall equal to grid 1 ij equal to island. Okay, island 1, which means if it's not a sub island, this one will be false. Okay, and as I go through this, what we're gonna do is sub island and equal to this, right? And equal to this. So, which means if anyone is false, this will become false. But we do have to go through this whole thing, and then we're gonna return is sub island. Yeah. So with that, I can come down here. If grid 2 ij is equal to 1, I can do check island, right? Check island. I can also do here. That's actually better. We do int, and we say if it's equal, then we be 1, otherwise it'll be 0. And every time when we do this, this is going to be times equal, right? So now here, if it's this, I can say res plus equal to dfs check island ij grid 1 grid 2. This is going to be grid 1 ij, right? Now one more thing. If it's equal to island, yeah, because it's inclusive. If it's a 0, that is actually false. And grid 1ij is not equal to 0. Yeah, I believe we need both. Right? It's the occurrence equal to the previous, and the previous cannot be 0. Then I just, set it to a really big value, right? Because I'll just say if it's equal to island 1, and then they will not equal to island 1. So basically, here, I can say, not here, and 22, right? We say if this is equal to 0, then I'm gonna just get a giant value. I'm gonna say integer dot max value. Otherwise, we do grid 1ij. Hold on. No, I didn't realize. All right, I'm back. We're almost done. Where are we? Yeah, we set it to, if it's water, we set to some value, but we need to go through the whole thing. And then, voila, that's it. Right? Okay, let's check solution 2. missing one. See if it's good. Where's our solution? Our solution is good. Cannot find symbol. What is this error? Oh. Oh, did you not? Sorry. I didn't get all the functions in. Yep. This looks good. That would be amazing if I just got this in the first shot. Use DFS to define islands. This should be faster than union find. We can hope. Oh yeah, faster. A lot faster. Twice. Alright, let's see what the solutions. PFS. DFS. Union find. Yeah. That's just like that. Okay. That'll be it. I will see you guys tomorrow. Adios.